video, we'll look at solving quadratic equations by graphing. So earlier on in the section that this is in, you probably talked about how to solve quadratic equations using square roots. That's the easiest way to solve quadratic equations because it works very similarly to the way we solve linear equations, just with the added step that we take the square root at the end. So for instance, if I wanted to solve this using square roots, I would start by adding 5 to both sides, just like I would if this was linear, meaning there wasn't a squared on the x. Then I would divide both sides by 2 and get x squared equals 16. And then we would square root both sides to get rid of the x squared. The square root of x squared is just x. And whenever I do this, the square root of 16 is 4, but there's also another answer that this could be, that if I think about what squared gives me a positive 16, negative 4 also works. So there's this rule that when we're solving an equation, if we have to put a square root in, that we end up with two answers. So we can put that x is positive and negative 4. And if we plug those back in for x and work out what this is, we should get 27. The problem with this method that makes it to where we have to have other ways of doing these problems is that this method only works when our equation doesn't have an x term. So the standard form for a quadratic equation is what's in this box right here, this ax squared plus bx plus c equals 0. And so in this standard form, they have accounted for having an x squared term, which we had a 2x squared, and they've accounted for having just a regular x, which we did not have in this example. So when we have a regular x somewhere in our problem, now all of a sudden, if I try to get my x's by themselves and then try to square root, I have too many x's to deal with. So we go about this in a completely different way whenever there's both an x squared term and an x. And one of the methods that we can use is to solve by graphing. So in another video, I will have details about how to graph quadratic equations. So if when we start this, you're a little confused about how we're graphing them, then go check out that video. It's 9.3 and it is graphing quadratic equations. The steps for solving by graphing is that we're going to write the equation with everything on one side so that it looks like this standard form. And when we write everything on one side, that means the other side is 0. We're going to rewrite the equation so that what we really have is y equals whatever this part of our equation is, because what we want to do is graph this equation. And so the reason we're allowed to put 0, or to put y where 0 is because if we do that, then on our graph, what we care about is where y is 0. And so we'll graph the function on number 3, and the answers to the equation end up being the x-intercepts, because the x-intercepts are where y equals 0. So let's take a look at this. I went a little too far. On example 1 here, it says represent the solution graphically, check the solution algebraically. We want to start by getting everything on one side. The easiest way to do that would be to add the 3 over, so that we have x squared plus 4x plus 3 equals 0. That's step 1. Now we're going to rewrite that as y equals x squared plus 4x plus 3. Now what we want to do is graph this. So when we graph equations like this, we care what a, b, and c are for standard form. So a in this case is 1, b is 4, and c is 3. We use the vertex formula negative b over 2a to get the x coordinate of our vertex. So that would be negative 4 over 2 times 1, which is negative 2 when you simplify it. And we use that to make a table of values. So we put an x and a y in a t-chart. We put this negative 2 in the middle of our table of values, and we pick numbers that are more negative, and then we pick numbers that are less negative. And these are the numbers we're going to plug into this equation to figure out what our y values are. So the easiest one to plug in would be 0, because we do 0 squared plus 4 times 0 plus 3. So these cancel, and we just get 3. So when I plug in 0, I get 3. Then I'm going to plug in -1. It's important when we plug negatives in for our x's that we put them in parentheses, because a -1 being squared like this turns it to a +1. Then we have -4 and +3. That ends up being 0. I plug in -2. And how difficult this is probably has to do with how good we are at mental math. You may not have to write anything down. You may be able to do the whole thing in your head, and that's great. But don't be afraid to, or don't feel bad if you have to write some of the steps down. Now, the way this works, if you've already been graphing quadratic equations, is if we did these bottom two correctly, the top two should end up being those numbers again. So we've got 9 minus 12 plus 3, which is 0. So that's good. The two that are next to -1 are both 0. That's what's supposed to happen. And then when I plug in -4, I get 16 minus 16 plus 3, which is 3, which again is good that those matched up. Now if I graph this, I have -4, comma 3, -3, comma 0, -2, -1, -1, 0, and 0, 3. And I can connect this with a curve. I don't connect them with straight lines. I make them curvy. What I'm looking for now to actually write my answers is I'm looking for where this crosses the x-axis. So that happens here in two places. It can happen just in one if our parabola was actually like sitting on the x-axis, the vertex was. But most of the time we will end up with two. And so one of our answers is right here, which this is the point -3, comma 0. The other one is right here, which is the point -1, comma 0. So what that means is that the answers to this equation we originally started out with are -3 and -1. So we can check this algebraically by going back to what we originally had, which was x squared plus 4x equals -3, and we can plug these in and see if they really work. So this is 9 minus 12, which really is -3. So that's correct. Then we plug in -1. That's 1 minus 4, which is also -3. So that worked. So we graphed it so that we could see what the x-intercepts were, and then we checked it by plugging it back in. And that's how these kind of problems are going to go. So let's look at another one. We need to get everything on the same side. We can either always move everything to the left, or we can look at this and say, well, it'd be faster to just subtract the x over, and that way we're only having to move one thing, but it's up to you. If I move things to the right here, I get -1/4 x squared. I'm going to put the minus x next so that it's in standard form, which is where I have x squared, then x, then our number. Now, if you solved it the other way, you would end up with a positive and a positive and a negative. And what's going to happen is these graphs will look slightly different from each other, but they should both give us the same answers. So it ends up not mattering which direction you go. So I'm going to replace the 0 with y. And we're going to graph this, so we need to know that a is -1/4, b is -1, and c is 3. This vertex is going to be a little tricky. Our formula is -b over 2a, so -1 over 2 times -1/4. We're going to have to think carefully about how this works. The negatives on top can cancel. And then I've got 2 over 1 times -1 over 4. So that's -2 over 4, which simplifies to be 1/2. Now, when I do 1 over -1/2, That's like saying 1 times negative 2 over 1, because we flip the second fraction when we divide. So this is negative 2. Another way of thinking of this is it's asking us how many 1/2s are there in 1, and there are 2 of them. So that's why we get that answer. That's our vertex, so that goes in the middle of our table of values. So we'll pick things that are more negative, and we'll pick things that are less negative. And we're just going to plug these in to our equation. So we're going to plug in right here where we've got y equals, because what we're trying to find is y. So we've got negative 1/4 times, I guess I'll plug in 0, it's the easiest. And we get 3. And then we plug in negative 1. It doesn't matter what order you plug them in. All that matters is that we plug them in to find y. So this is positive 1 times negative 1/4, which is negative 1/4. This is a negative 1 is a positive 1 plus 3. So that's negative 1/4 plus 4, which is 3 3/4. And we might as well leave it as 3 3/4 because that's easier to graph than its improper fraction form, which would be 15/4. So we can tell pretty close where 3 3/4 is on our graph. It's a lot harder to tell where 15/4 is. Now let's do negative 2. So negative 2 squared is 4. Negative 1/4 times 4 is negative 1. Negative 2 turns to plus 2. So we've got negative 1 plus 5, which is 4. And what should happen is when we plug in negative 3 and negative 4, they should repeat. What I recommend is that if you're pretty confident about your work on the first two, then it's not necessarily a bad thing to go ahead and copy them down to the other two. But if what you're doing is for a quiz or a test, which is worth more points than just the homework that you're practicing on, it's a really good idea to go ahead and work out what those are to make sure that you're right. So we want to graph 0, 3, negative 1, 3 3/4. And then we want to do negative 2, 4. And then negative 3 is 3 3/4. And negative 4 is 3. Now we've actually got kind of a problem here because we don't have enough points. This is a parabola opening down, but the question is, where exactly is it going to go through the x-axis? And as a mathematician, I don't want to guess that. I want to actually figure it out. So let's try plugging in 1 to see what we get. And we're just going to basically plug in until we get to a place where we can see where it goes through the x-axis. So this is negative 1/4 minus 1 plus 3. So that's negative 1 1/4 plus 3, which there, you need 3/4 to get up to 2, and then another whole to get to 3. So this is 1 3/4. So we are getting closer to the x-axis. 1 is at 1 3/4. So maybe 2 will work. Let's hope 2 works. Otherwise, we're going to be plugging in all day. Negative 1/4 times 2 squared minus 2 plus 3. So this is 4. They cancel and leave me with negative 1. And this does give me 0. So when I plugged in 2, I got 0. That's one of our answers. If we do our symmetry here, then at negative 5, we should be at 1 3/4. And that means at negative 6, we should be at 0. So the answers on this one are -6 and 2. So if all we needed to do was graph this, the first 5 points that we picked for our table of values would have been fine. But because we needed to actually see exactly where it went through the x-axis, we had to actually plug in and find more numbers. And so sometimes that'll happen and sometimes it won't. It just depends. But if you can't tell what the solutions are just from those first 5 points, you need to keep plugging things in. This is the final example on this. So everything is actually already on the right side, well, the correct side, which is the left side. So we're gonna write this as y equals. We've got A, B, and C. So our vertex is -12 over 2 times 2. So -12 over 4, which is -3. Now, what we want to do is put our table of values. And I don't actually remember if there's anything that tricky that happens with this problem. So you might think about pausing the video right now and working out the rest of this on your own to see if you're doing it right, and then play the video and see what I actually do so that you know if you're doing it right. So we pick numbers that are more negative, numbers that are less negative. We're going to plug all these in to our equation. You can plug them in any order that you want to. So this is 2 times a positive 1, then we minus 12, then we add 10, and all that together makes 0. So that's actually one of our solutions. And then we do 4 times 2 is 8, minus 24 plus 10. These numbers are a little bigger than would be nice, but that's okay. This ends up being -6. Then we do -3. And get 9 times 2, which is 18, minus 36 plus 10. So that's 28 minus 36, which is -8. And if we did the first 2 right, we can just repeat them using our axis of symmetry and then plot this. So -5, 0, -4, -6, which is quite a jump, -3, -8, -2, -6, and then -1, 0. So there wasn't anything tricky about this problem compared to our other ones. Like example 2, the hardest part was dealing with those fractions and the fact that we had to plug in extra numbers, but we've got our answers right here that x would equal -5 and -1. One of the reasons that this is actually a really cool method is because at some point in your math career, you'll be able to use a graphing calculator, and the graphing calculator will make this faster for you. The drawback to this method is that you may notice that we got whole number answers for each of these. I had to actually go out of my way to get equations that would give us whole number answers, as well as nice vertices, or a nice vertex. Lots of problems aren't like that. Lots of problems give us fractions or radicals, and if we're graphing, it is very hard for us to tell what those exact values are. So this method has its pros and cons, and its pros increase once we're allowed to use a graphing calculator or a computer. But it is a nice way to see that, hey, this is actually visually what's happening here. This is why these are the answers. Also, I'll throw out there that sometimes there's another case. Like I mentioned that we could have a graph that sits on the x-axis. So we could have a graph that just has one solution because it sits on the x-axis. And so that solution would just be that x equals 4. We can also have graphs, though, that don't have a real solution because they don't actually cross the x-axis at all. The highest point here is at -5 for y, and it never ends up going through the x-axis. So we would say that there are no real solutions on this one. So those are our kind of three cases we can have. We looked at three problems where it intersected twice. We could intersect once if it's sitting on the x-axis or hanging from the x-axis, or we could actually have no solutions, no real solutions. So that is solving quadratic equations by graphing.